Hello everyone, welcome to today's presentation. This one will be on the history of smallpox, a deadly epidemic, and its conquest. This is for the Virology course here at Florida International University, MCB 4503, presented by group number 3. I hope you enjoy. Here in our introduction, I want to overview how our presentation will be structured. Beginning with the history, we'll be diving into the interactions of the smallpox virus with human civilizations at different time periods. So we'll be discussing the early ages, we'll be discussing Middle Ages, and we'll be discussing colonial America, as well as the early prevention methods and the eradication, as that will be discussing the vaccination, the history and how it was developed, by who, when, and where, as well as the virus's mechanisms and how it functions, and also lastly the vaccination to full circle back into the overall theme of how things develop through time. Now, smallpox is one of the oldest viruses, and it's one of the most feared diseases in human history, caused by the Varroa virus. It spreads easily from person to person. It often led to high death rates in the past. Its symptoms included high fever, weakness, and unique skin rash that often left scars on survivors. You'd see many very bumps all over the body with like pus, and as well as causing some scar tissues if you were able to survive the interaction. Heavy scarring tissue, and also sometimes often the loss of eyesight due to the damage. Before its eradication in the 20th century, smallpox influenced wars, trades, populations, and even led to early breakthrough in medicine, like variolation and later vaccination. In this presentation, we'll explore the smallpox spread through ancient and medieval societies, as well as its impact on the world. Early history. Smallpox has been referenced since the 4th AD in China and 7 AD in India, as well as through the Arab expansion. We've seen spreading of smallpox into northern Africa, Spain, and Portugal. Because smallpox is a highly contagious disease caused by the Varroa virus, known for producing the pus-filled sores on the skin, as we know it, it spread mostly through direct contact with an infected person or contaminated items, such as clothing and bedding. Although the exact origins of smallpox remain unclear, archaeological evidence, including mummified research from ancient Egypt, suggests it may have been existent as well in the early 2nd millennium BCE, notably due to lesions resembling smallpox found on the mummies from Egypt's 18th and 12th dynasties, including that of Ramses V, supporting the theory that the disease was present during that period, though definite diagnosis is limited to early scientific capabilities. While ancient written records from the Nile and the Fertile Crescent mention devastating plagues, they do not clearly identify smallpox as we know it today. However, the dense populations and interconnected trade routes of these early civilizations likely facilitated the spread of various infectious diseases due to the common route being shared by numerous people and being very active. However, historians speculate that Egyptian traders might have transmitted smallpox to the Indian subcontinent during the 1st millennium BCE. The earliest written description of smallpox appears in the 4th century Common Era, China. And by the 6th century, increased movement along the Silk Roads accelerated its spread across Asia. The disease reached the Korean peninsula and Japan, becoming epidemic in this region. Particularly devastating epidemic occurred in Japan from 735 to 737 Common Era, killing an estimated 1/3 of the population. This led to severe labor shortages, declining agricultural production, and reduced tax revenue, significantly weakening the central government's control. By the 7th century, smallpox had become an epidemic in the Indian subcontinent, and Muslim expansion helped spread it to North America, Spain, and Portugal. In the 9th century, Persian physician Reyes offered one of the first clinical descriptions of smallpox, successfully distinguishing it from the measles. The disease continued to spread over the next several centuries, reaching Anatolia by the 10th century, Central and Northern Europe by the 13th century, and West Africa by the 15th century, largely via trade, conquest, and exploration, especially through Portuguese expedition. Despite its devastating toll, smallpox spread also contributed to early medical advancements. Intercultural exchanges along trade routes encouraged the transmission of medical knowledge, including the development of virolation, an early form of inclination, practiced in regions like India. This technique involved deliberately exposing a healthy person to make from a smallpox sore in order to induce a mild infection and lasting immunity, known as Tika in the Indian subcontinent. This practice laid important groundwork for the development of modern vaccination as we know it today. Smallpox in the Middle Ages. During the Middle Ages, smallpox became a global threat, spreading across continents as trade routes expanded and empires grew. It became a constant presence in many regions, causing recurring outbreaks and devastating entire communities. The disease did not affect health as it disrupted economies, slowed population growths, and even changed the course of history in some areas, as in comparison, it didn't just affect the health. At the same time, this period saw the beginnings of medical innovation, likely early forms of inoculation as people tried to protect themselves from the disease. Smallpox was a highly lethal disease as well, with a mortality rate around of 30%, and survivors often suffered from blindness and extensive scarring due to the boils with the pus. Smallpox spread rapidly across Asia, Africa, and Europe. This is why in many regions, because of the trade routes, it became so common, especially during the warfares and all the traveling around the time. Because of this long-lasting effects, we could see that in certain areas, such as like Japan and Korea, with the previous slide, how it could stay in one region for quite a while without any sort of vaccination. Impact on populations in European colonies and America. Smallpox was one of the most deadliest diseases in colonial America, especially for native populations who had no natural immunity. Entire communities were devastated. In 1721, when smallpox hit Boston again, Cotton Mather's promoted an early form of inoculation in which he learned about from a practice. He had zero experience. However, with scientific reports coming out of Europe, he was able to begin inoculating people, which at the time sparked intense public debate. While most doctors rejected the idea, many people, especially clergy, supported it. Interestingly, as a fun fact, Benjamin Franklin was involved in publishing articles against inoculation in his brother's newspaper. However, after losing his younger son to smallpox, he became a strong supporter of the practice and deeply regretted not having acted sooner. Later, during the Revolutionary War, George Washington secretly implemented a mass inoculation program for American soldiers, quarantining them to stop the spread. This likely saved the army from being overwhelmed by disease. Then, in 1796, Edward Jenner developed the first true vaccination by using cowpox, a safer alternative that led to the eventual global eradication of smallpox. This story will be expanded on later in our presentation. The takeaways is that during the time of colonial America, it was the most dreaded diseases. It was brought in by European settlers. The mortality rate for natives were 100%, and frequent outbreaks in Massachusetts during the 17th century had occurred until the vaccination was improved.
Hi, my name is Brandon Carrillo, and I'm going to be covering the development of the smallpox vaccine. Before vaccines were used, the first method of preventing smallpox was through variolation. Variolation was where one deliberately infected someone with a matter of smallpox sore, usually by scratching or inhaling it, so that they would catch a less severe form of the disease and therefore be immune. Variolation was done for hundreds of years and practiced in the regions of China, Africa, and the Ottoman Empire. Scabs of smallpox were blown up the nose as powder in China. The virus was injected into the skin by incisions in Africa and in Turkey. These measures did not work, but did reduce the deaths from smallpox, specifically when one compared to someone that contracted it naturally. But variolation wasn't safe. Sometimes it caused actual infection, and people could still go into infecting others with smallpox. That is the reason why, even though it was an improvement, violation later gave way to Jenner's more efficient and safer cowpox-based vaccine. But violation did create the notion that controlled exposure could be followed by immunity. We are first going to talk about one of the most important turning points in medical history, the medical work of Edward Jenner in 1796. Jenner was an English country doctor who made a remarkable observation. Edward noticed that milkmaids who had contracted cowpox did not seem to catch smallpox, which at the time was causing multiple deaths around the world. Jenner came up with a hypothesis that cow exposure would immunize a human against developing smallpox. In order to test it, Jenner conducted an experiment on an 8-year-old boy named James Phipps. He took material from a cowpox lesion on the hand of a milkmaid and infected the boy. Phipps developed a fever but quickly recovered. Then weeks later, Jenner inoculated him with smallpox, and he didn't become infected with the virus. This was revolutionary. Jenner had shown that immunity could be induced by exposing someone to a related, less dangerous virus. He called this technique vaccination. This concept was born from simple observation and bold experimentation. It laid the foundation for immunology and changed the course of human health forever. After Jenner made his findings public, a world of discovery spread quickly all throughout Europe and America. Doctors and governments began instituting vaccination campaigns in an effort to repress smallpox. By the early 1800s, vaccination for smallpox was common all over the world, and the death rate had a major drop where vaccination had been instituted. But the initial success came from its own set of problems. The biggest issue was preventing the vaccine. There were no freezers or cold chains in the 19th century, so maintaining the vaccine's viability for long trips was problematic. Some resorted to arm-to-arm transmission, and in so doing, new dangers were added. A public resistance, too, became a challenge. People were skeptical or scared, particularly since early vaccinations were not always explained well. In spite of all of that, the government realized the benefits of it. England and France went as far as to establish laws requiring vaccination against smallpox. In the United States, those efforts followed. According to figures from organizations like CDC and WHO, regions which adopted the practice saw a steep reduction in smallpox infection. Those early campaigns proved vaccination could save lives on a large scale. Smallpox also plagued the world well into the 20th century, far beyond 100 years since being immunized. This was extremely durable. It was extremely durable in parts of South America, Asia, and Africa. The World Health Organization initiated a concerted effort to eliminate smallpox in 1967. The Global Smallpox Eradication Program was put into effect. The WHO's strategy had two main parts. First, they aimed to vaccinate as many people as possible. And second, which was most important, they implemented active surveillance. This meant searching for new cases, responding rapidly, and containing outbreaks before they could spread. The initial stage of the program did not go as planned. The logistical challenges included not enough supply of vaccine, the vaccine reaching rural districts, and a challenge to the effectiveness of the vaccine at warm temperatures. The vaccine had to be freeze-dried to be able to work in tropical climates. Surveillance and containment became the heart of the eradication strategy. Surveillance meant having trained teams go village to village looking for anyone with a suspicious rash or fever. Cases were immediately reported and confirmed through lab testing. Once a case was found, containment kicked in. This is when the patient is isolated and vaccinating everyone who had been in contact with them, and this was known as ring vaccination. Instead of vaccinating an entire population, they created a ring of immunity around each outbreak. This strategy was much faster and more cost efficient than mass vaccination, and most importantly, it worked. Even with new cases, WHO teams acted quickly, isolating isolating the patient and stopping the virus before it could spread further. One powerful example of how effective this was in India. Surveillance teams used rewards to encourage people to report smallpox symptoms. Thousands of workers were mobilized, and as a result, outbreaks were identified and controlled within days. Surveillance and ring vaccination proved to be brilliant and a practical solution to a global challenge. All this effort came to fruition. The last naturally occurring case of smallpox was in 1977, said to be a man named Ali Moa Malin in Merka, Somalia. He was a hospital cook and hadn't been vaccinated and got infected while handling patients. Ali recovered, and luckily there were no secondary transmissions. In the wake of this case, teams conducted high-level surveillance within the region and worldwide to ascertain that no new infections were being caused. Molecular surveillance tools and genetic tracking confirmed that the virus was no longer circulating in the human population. This was a wonderful landmark, the last time naturally occurring smallpox ever appeared, and it meant that the world was about to experience a great victory. It wasn't until May of 1980 that the World Health Organization, otherwise known as WHO, made the official announcement that smallpox had been eradicated. This was the first time ever in the world that a disease had been eradicated by human efforts. The eradication of smallpox showed what could be achieved by the world uniting as one. It was not science that had made it possible. It was cooperation, dedication, and resolution at the international level. Countries had no common language, the separate economies, and different political philosophies were joined together in a common endeavor. This victory had a lasting effect as well. It paved the way for future eradication efforts against diseases, including global efforts against polio and measles. Smallpox eradication ranks as one of the greatest public health victories of all times, and it all started with a milkmaid, a cow, and a fortunate brainstorm by Edward Jenner.
Hi everyone, my name is Jasmine, and I'm going to be picking up a presentation by beginning with the smallpox eradication efforts. So following the eradication of smallpox, meaning that the outbreak was contained, the effectiveness of vaccines were firsthand observed, which led to the development of new public health laws, such as mandated vaccines and emergency health response laws. These were a way to make sure that the outbreak of this virus wouldn't happen again, or to eliminate any future outbreaks, or at least diminish the amount that would happen. And so the eradication of smallpox led to the understanding that global cooperation is necessary for the eradication of diseases. So if anything were to happen in the future, different countries came into place, and they know that they have to work together in order to keep an outbreak to this extent underway. So, for example, when COVID-19 came, again, countries teamed up and created laws that were similar to one another in order to diminish the outbreak and keep it from spreading furthermore. And this emphasized the critical role of fast detection in viruses such as smallpox and COVID, as they do result in a lot of deaths and can put a hold on a lot of different things. So the fast detection of these diseases helped surveillance and response systems from health networks. Okay, so now moving into molecular mechanisms of the smallpox infection. It begins with the variola virus entering through the body's respiratory tract and then attaching to a singular host cell. This is what starts the infection. And then the virus, one of the reasons that the smallpox virus was so successful and created such an outbreak was that the virus produce a protein that inhibits the host's natural immune response. So normally the body would attack the virus and try to prevent an outbreak from happening once it enters through the respiratory tract. But because of this protein, then the body wouldn't recognize that it was there early enough, and then the host would become infected and sick. And then, so following the entry of the virus, it would overtake the cell that was first infected, and it would hijack its functions and replicate its own DNA. Therefore, once the DNA was replicated, it spread the infection to other cells, and once enough cells were infected within the host, then the host would start feeling the effects of the smallpox virus. So because of the protein that is created by the variola virus, in many cases, the immune system was too late to prevent the infection of the smallpox virus, but this is the immune response to the smallpox virus. So the body, once it did recognize that there was an infection within the body, it would send out its immune response through inflammation and increased immunity cells in order to try to fight off the initial infection. And so within the regular immune responses, antibodies are utilized in order to keep the virus at bay, while T cells are a bit more aggressive and they go after the infected cells within the body and kill them in order to prevent more DNA replication and more cells from becoming infected. So by getting a vaccination, you would have a little bit more of a chance of not getting infected, or the host would have less of a chance of being infected, as it promotes an immune response by stimulating the body into producing more antibodies and T cells in order to prevent any future infections of the smallpox virus. Okay, so following along, we're going to be discussing the role that genetics partakes in smallpox resistance. So there have been a lot of recent studies that have been focusing on the role that genetics have within the resistance to the smallpox virus. There are some genetic variations that are present that indicate that some individuals might be less or more prone or susceptible to contracting the smallpox virus. These genetics variations may also affect how sick a person will become with the smallpox virus once infected. And so these studies that have been coming out are critical for understanding how specific human genes are linked to different responses of human infection, as well as the molecular interactions between the virus and the host. This is important in order to understand vaccine development. Even though the smallpox virus has been eradicated, this is still important to understand how to create more effective and safe vaccines for maybe a new strain of the smallpox virus or other viruses that will be coming out. So this was helpful during the COVID-19 pandemic. And this also leads more into a newer realm of medicine, that's personalized medicine, understanding how someone's genetics can differentiate different viruses for the individual. So this also helps give them an understanding of how they should treat this host or this individual based on their genetics. Okay, so last up, the genome of the variola virus. So the variola virus genome encodes about 200 genes and contains a complex organization of these genes that influence the virus's ability to evade the human immune system. And so the structure and function of the genome of the virus allows for the coding of crucial enzymes as well as proteins pertaining to the virus's replication when inside the host cell. And then, due to some of the recent advancements of genomic sequencing, the sequencing of the variola virus genome allows for some insights into the mechanisms that allow for the development of new therapies and, again, vaccines that may not be only for smallpox, but this allows scientists and researchers to understand the genome and understand how to create more effective and less harmful vaccines for the human body.
My name is Amanda, and now we're going to be moving on to the topic of the lasting legacy of smallpox eradication. So in the year of 1980, smallpox was finally eradicated, marking a significant milestone in both public health and medicine. Being the first disease entirely eradicated by human efforts, it demonstrated that vaccination campaigns and international collaboration could successfully eradicate fatal illnesses. And this eradication campaign demonstrated that mass vaccination may successfully halt the spread of a virus if it is planned and carried out correctly. Planning for public health emergencies such as COVID-19, Ebola, and measles has been impacted also by this. And coordination between nations, the World Health Organization, and international health organizations enabled the successful elimination of smallpox. And it also showed that when countries collaborate, global health issues can be handled, even if it's as fatal as smallpox. Modern vaccine science has been affected by the lessons learned during the creation of the smallpox vaccine. It has a long-lasting impact on vaccination programs for other infectious illnesses by influencing the development, distribution, and monitoring of vaccines. The smallpox campaign served as a template for subsequent initiatives to eradicate the illness. The tactics, which have subsequently been used to other international health programs aimed against illnesses like polio and guinea worm, included mass immunization, surveillance, and quick reaction. So here you see a picture in this PowerPoint of the anti-smallpox procession wending its way through Delhi streets in celebration of the eradication of this disease. Now we're going to be talking about the potential risks between smallpox and bioterrorism. So despite being eradicated, smallpox's high death rate and infectious nature raise concerns that it may be used as a weapon because of how big the outbreak was. A reintroduction might have disastrous consequences because the majority of people are no longer immunized. So that means they are prone to getting this illness if there's another outbreak. Two high security laboratories, one that includes in Russia and one that's in the United States, called CDC, continue to hold live smallpox virus samples. Strict biosecurity procedures are in place at these establishments to guard against any unintentional or purposeful release. The World Health Organization has been debating the issue of whether to eradicate the smallpox virus's residual stocks for decades. Others support elimination to remove the possibility of unintentional release or abuse, especially by terrorists, while others claim that keeping the virus is essential for research into new vaccinations, diagnostic equipment, and antiviral medications. So now we're going to move on to the topic of the impact of smallpox eradication on vaccination policy. So the first ever organized worldwide smallpox eradication operation demonstrated that immunization may lead to eradication. It demonstrated the significance of international cooperation, surveillance, quick outbreak response, and broad vaccination coverage. The design and execution of various vaccination campaigns, including those for polio, measles, and even COVID-19, are now modeled after same tactics. Smallpox initiatives also increase awareness of the idea of herd immunity around the world. The World Health Organization, also known as WHO, acquired a key role in planning international vaccination efforts following the successful eradication of smallpox. To adhere to WHO rules and a guarantee systematic vaccine distribution, nations started creating their own national vaccination programs, such as the Expanded Programme on Vaccination, or also known as EPI. Countries began to standardize vaccination regimens, especially those for children and high-risk populations. Based on the smallpox campaign's models, these organizations now also oversee vaccine safety, provide funds and resources, and contain outbreaks. Because it employed a live virus, which is linked to smallpox but does not infect people, the smallpox vaccine was different. Unlike many contemporary vaccinations, it did not require a cold chain, was extremely effective with a single dose, and left a noticeable scar. Modern vaccines, such as those for COVID-19 or influenza, make use of cutting-edge technology like mRNA, protein subunits, or inactivated viruses. Modern vaccinations are frequently safer and more targeted than the smallpox vaccine, although they do require numerous doses or boosters and more cautious storage. The contrast demonstrates how vaccination technology has developed while still drawing on foundations given by the smallpox vaccine. So now we're moving on to the topic of the molecular basis of vaccine development. In the year 1796, Edward Jenner created the first vaccine using material from cowpox, a related virus that was less harmful but remained comparable to smallpox, enough for the immune system to produce protective immunity. This idea is based on the idea of cross-reactivity, which states the immune cells and antibodies developed to resist one virus, which was the cowpox, and can identify and neutralize another, which would be the smallpox. Over time, live attenuated viruses that could stimulate a powerful immune response without causing serious illness were used to improve this fundamental mechanism. A weakened version of the virus that may still multiply in the body but does not cause major illness is included in live virus vaccination, such as the smallpox vaccine. This method frequently only needs one dosage and precedes a powerful and persistent immunological response. Viruses that have been destroyed or made incapable of replicating are used in inactivated vaccinations. Although they usually result in a weakened immune response and frequently required for booster doses, they are safer for immunocompromised people. In the 1950s, freeze-dried vaccinations were created because they didn't require refrigeration, which made them easier to carry and store. This allowed for vaccines to reach fairway regions and maintain effectiveness even in hot weather. Significant vaccination during the smallpox eradication program was made possible by these advancements, which also made vaccines more stable, accessible, and user-friendly, ultimately contributing to the global eradication of smallpox, a straightforward tool that facilitated faster and easier vaccine delivery during mass campaign. So here you can see a picture of a cover of a magazine of the World Health Organization saying that smallpox is dead. So now we're going to be summarizing some of the major points that was stated about smallpox in this PowerPoint. So for more than 3,000 years, people have been afflicted with smallpox, a disease caused by the Variola virus. The disease starts out as a high fever and fatigue, followed by a distinctive rash that first appears primarily on the face, arms, and legs, then develops into fluid-filled spots. The disease was once one of the most dreaded illnesses in the world. The infection is caused by the Variola virus adhering to host cells after entering the body through the respiratory system. Because it produced a protein that prevents the host's normal immunological response, the virus was clever enough to avoid detection by the body's immune system. After entering the host, the virus would seize control of the cell and its processes in order to duplicate its DNA and infect more cells. In the year 1796, Edward Jenner made the discovery of the smallpox vaccine. America and Europe quickly adopted Jenner's vaccine, and the smallpox mortality decreased as a result of the vaccination initiatives. Obstacles with this vaccine included public distrust and vaccination supplies. Following the launch of the vaccine, statistics indicate a decrease in cases. In the year 1980, WHO proclaimed smallpox was eliminated, the first illness to be completely eliminated by vaccination. Extensive international cooperation between nations and organizations proved that illnesses can be eradicated worldwide. And lastly, this is our reference slide that we obtained all of our information from for this smallpox presentation.